Thank you very much. It's really, really a pleasure for me. You have been so kind with this presentation, and also thank all the organizers for being here. It's really a pleasure to talk about AI in this audience, and in particular on the skills I think should be very relevant in the future for dealing with this AI. So I will be very schematic, and I will try to define some questions and so that you can get some take-home messages. First of all, are we really in the age of the AI? So this is an important point. You should think really what AI is. So I think that most of you will think about ChatGPT or similar stuff. But I will start thinking about other kind of artificial intelligence. Indeed, as an AI researcher, I must say to you that all the stuff that are currently known as large language models are not so really very hot in our research domain. And I want to point out some other kind of application. For instance, this is an example of a self-autonomous driving car with some exception. In particular, you see that the car looks inside if you are maybe distracted because you are just typing on your phone, and then can decide, well, I would like to go automatically with the machine. And it's interesting, this is a picture taken from our researcher in MIT. It's interesting because here you can see also behind the scene the artificial neural network that really takes care of having a look at the street. Well, this is an interesting project. A student of mine made an active role in this project. It's a self-autonomous vehicle, but now this is a bicycle. And these are real-life applications, so these are reality. And in particular, you see here that you need a number of sensors, a number of actuators, you need reasoning, you need a lot of things. And in particular, it is very tricky because in this kind of application, you must take care of an environment which is very and highly dynamic. Well, other example, this is generative design. When I think about generative AI, I hardly think about drawing a picture in some DALL-E system or something like that. I typically think about the systems. So these are systems that help engineers in producing novel patterns, and you can start some novel project by asking the AI system to use the experiences in the database in order to define some novel kind of ideas. And all of these are real-life applications. And of course, urban regeneration. Now we can do a lot of things. For instance, you can have a street that you do not like, and then you want to say, okay, what if I add something to this street and make it more beautiful? And it becomes an interesting way to interact with the decision makers. Well, digital twins, just want to mention another application. This is an impressive digital twin. As you see, everything has been completely reconstructed, and you can use these digital twins in order to model and to reason about, for instance, flows of population, about environmental scenarios, and so on. You can do a lot of stuff there. Of course, surgeon support. So in the medical domain, we all know that artificial intelligence is already there. It can be used in robotic assistance surgeon situation. In particular, these are also applications we do at my universities. And so there are a lot of skills required. So this is another one. So first of all, the first message is when people tell you that ChatGPT is AI, then this is really not the case. It's just the surface. And maybe I want to tell you that also the market related to artificial intelligence is not focused on large language models. All of these are what nowadays define artificial intelligence. There is a huge amount of application. And in particular, in the domain of industry and in the domain of medical application, all the large language model stuff are not really what we are currently expecting to be the breakthrough in the future. So this is the first message. Second message. Well, we have all this kind of application. What we really need? So first of all, we need the technical skill. And now this is interesting because it's something obvious, but things are going very different from what one would expect. So these are a kind of survey that was collected in Italy over all the small and medium enterprises. It was a very nice survey. And so it was asked, all these enterprises were asked if they would like to implement AI in the next future. And all of them say yes, we would like to implement AI. And then after that, we asked, and why you did not already implement the AI system in your industry, in your application? And these are the typical answers. The typical answer are, okay, we have difficulties in finding business case, so in other words, we really want to know how to use AI. We need large investments. I really don't agree with this, I partially agree, let's say, with this answer. Currently, this is not a matter of investments, but the third point is the most intriguing one. So, everyone in Italy, but this is a matter that really spread worldwide, experience a lack of technical skills. So this is an important point. I must start with saying this. So we really need technical skills. And for instance, this is a worldwide survey by Deloitte. They ask to the organization, to their organization, if they are ready. And surprisingly, only the 20% of them say that they are ready in terms of talent, in terms of the people that should create and deal with this artificial intelligence system. So, interestingly, AI is something that everyone is talking about, but unfortunately we have very, very few people that are able to do and reason to deal with the AI system. And indeed, so this is also by McKinsey, just to tell you that this is consistent with all the great player in the world. And this is something which should be really understood with care. In particular, since a long time I was impressed by this report by World Economic Forum that every year says that in the future there will be more and more jobs because of AI. So it is a very positive kind of view. It says, okay, there will be a balance of jobs, some jobs will disappear, other jobs will appear, but the World Economic Forum is always consistently saying, please take care that in the future, novel jobs there will be. So 78 million of jobs, this is their most recent record. And you see the kind of skills that are required. But now the point is, do we have these 78 million of workers that are able to deal with AI? The answer is no. And indeed, I think that a more kind of elaborate approach is this one by the Tony Blair Institute, in which you see that there is at some point a peak of unemployment. This peak of unemployment is not due to the fact that machine will replace humans in the world. It's due to the fact that enterprises are asking for jobs that do not have people applying for. So this is the question. So if you go to an enterprise and say, okay, why do you really are not thinking about novel projects, about using AI? Their answer in Italy and everywhere in the world is, we really miss talents, we really miss people that are able to define this kind of application, this kind of projects. So this is an important point. So the first message is, unless if you want that all this AI stuff is a kind of hype, we really need people that are able to do and are able to work in the AI. But there are other skills. And I think that most of my talk will be about the other skills that are required. So I want to be serious, technical skills are on the other end. But to understand the other kind of skills that are required, I want just to spend a few minutes on how did we get here. So, why I need this kind of very brief retrospective view? I mean, because the origin of this AI system started basically in 1950. I usually want to consider and to define the figure there of Alan Turing. I know you know that Alan Turing did not define artificial intelligence as a word, as a name, but I think that all the ideas of artificial intelligence are there, and moreover, I really appreciate that he always talk about intelligence of the machines, so just to really say that these are machines that have to be used. And in this period, by looking at the idea of Alan Turing, we all developed approaches which basically do the following. We have experts, so this is how we intended artificial intelligence up to the 80s. We have experts, we ask these experts about their knowledge, and we try to formalize their knowledge in terms of formal languages, logical rules, whatever, and we try to build intelligent systems that at the time were called essentially expert systems. Okay, this was the approach. For instance, I asked to, in a medical domain, I asked for information related to medical stuff, and I try to define this information. Notice that the first approach is a kind of if-then-else approach, so very simple. So I build a very large knowledge bases in which I say, okay, if you are in this scenario, then do this, if you are in this other scenario, do this, and so on. Well, starting in the 80s, we had stochastic distribution, we had probabilities. It is hard that we are in a very precise sharp scenario, we need to mix different scenarios, but more or less the idea was there. So, taking the knowledge from humans. What happened? Well, it happened that this approach did not scale, and you know that at the end of the 80s, basically we went into a kind of AI winter. So no one no longer talked about the AI system. And so what happened? It happened that nowadays we are talking about AI because of a completely different perspectives, which actually is even antecedent to Alan Turing. Indeed, in 1943, McCulloch and Pitt started reasoning about our neurons and tried to define a model, a mathematical model of our neurons. And why they were so fascinated by these neurons? Because these are different from the standard cells. In particular, there is a concept, if you really think about that, of input and output. So a neuron is something which receives an input, some stimulus, elaborate the stimulus through a nucleus, and then provide the result of the elaboration as output. So there is a very nice connection. It is not a kind of cell that is isolated or which interacts in strange ways. It has a very clear pattern. Input, elaboration, output. And so this idea was used by Frank Rosenblatt. Maybe I'm the only one who mentioned this guy to you, but it was very important in the history of AI, because for the first time he posed the question, can machine learn? So can I build a system made of neurons, artificial neurons, such that they take the knowledge from people, not by asking people. This was the tricky point, the difference with respect to the previous experiences. But just looking at what people did in the past. So it was a completely different perspective. Well, this perspective went again to an AI winter up to a certain year. So maybe if you talk with other scientists, all of them will take you a different year. For me, the really point where the current trend started is 2012. So what happened in 2012? We as computer scientists were every year are involved in a competition in which we try to recognize images of everyday life. So this competition is called ImageNet. So we try to compete, we try to understand that this is a bottle, okay? And up to this year, we used the old-fashioned approach of computer vision. So in order to understand that this is a bottle, there is a programmer which describes a bottle. And you can see how hard it is describing a bottle, right? So it's a really tough job. So how to describe, so you have this, and so it's a very complicated stuff. In this year, a neural network won the competition. And the neural network has no internal description that this is a bottle. So this is the interesting point. So it has just looked at many different bottles, try to understand what a bottle is. Now, what I want to tell you is that this is really the starting point. In 2012, we have the first approaches, and after 4 years, the system that are nowadays used to recognize images achieved the so-called superhuman performances. So what does it mean? It means that you can see these two curves that goes up at a certain point and became more and more affordable with respect to humans. And so this task is completely won by machines. So nowadays, this is the reason why in your car there are systems based on neural networks to recognize whether you have some road sign, for instance. Okay? And the last part, it's clear about the ChatGPT like stuff. So we then improved these kind of techniques and we went to ChatGPT. So why I have emphasized more the images? Because first of all, our great achievement started from the images, and then because I want to show you the relationship between this language and the images, which is the key ingredient, the key technical ingredient we need to understand in order to really appreciate the kind of skills that are required in the future. Okay, what about large language models? So I want to go behind the scene now. And this is a kind of neural network that can be used to recognize, for instance, a road sign. Okay, a stop. So how it works? It works very easily. So the green bullet there, the green circles, are the neurons, right? Precisely the abstraction of the neurons. I told you that it comes back to 1943. Notice an interesting point. Every image is just a set of pixels. Okay? Are you with me? And every pixel is a number. So every number is just the stimulus that comes at the neuron. So for instance, here to this neuron, some stimulus arrive that is the corresponding pixel here. For instance, 200. So it's a number. Okay, what happens with this neuron here? This neuron here, precisely as in the definition, as in our brain, takes the stimulus that comes from the previous neurons, but it has one flexibility, and this is the key point. So this is the only technical thing I ask you to reason about. It can amplify the stimulus by multiplying it by some parameter. For instance, I just multiply by 3, by 2, by 8, or I can even reduce the stimulus. For instance, I can multiply by 0, so it means that I will completely eliminate that stimulus. Okay? So I give the neuron the flexibility to understand which stimulus to emphasize and which stimulus to forget. And so, what is inside the neural network is just a weighted summation. That's it. And the numbers that are there, times 3, times 2, times 8, are the so-called parameters of the network. So you can see that, on the one hand, we start from an image, which are just numbers. We process all these numbers, and then we end up with a number that we interpret in a completely arbitrary way. For instance, we can say, okay, if this number is greater than 50, then maybe it's yes. We understood it as yes. Otherwise, we understood it as no. So it's completely arbitrary. But you can see that inside, behind the scene, there are just very simple mathematical operations. Addition, multiplication. That's it. Okay, if I start this example, so my students will build this neural network, I provide this stop, what will be the answer? Well, the answer will be, I don't know, maybe yes with probability or no with probability 1/2. So nothing has been defined, so how it can really recognize a stop. And then the important point comes into play. If the answer is no, when I provide as input stop, then we have defined as a computer scientist some algorithms that are able to change the parameters. So this time 3, time 2, time 8 can be modified. So when maybe we are able to recognize that it's not 3 the right term, but it's 3.2, we're able to adjust this parameter in a way that when we see the sign, the road sign, the stop, we are able to recognize it. Notice that this is done completely algorithmically, so there is a very simple mathematical formulation. It's a derivative. Well, if you have some background in mathematics, it's a really simple derivative, and we just compute the zero of this derivative. We do methods like running the shed. That's our standard mathematics. But then what is the point? The point is that if we then provide another stop, what is the probability that over this other stop everything is fine and the answer is yes? The probability is still 1/2. Because the network is not seeing this stop. And so clearly the parameters are completely free again, and there is no relationship between the stop and the structure of the network. So it means that when you see a stop and it makes a mistake, then you have again to set up in a different way the parameters. And again and again and again. So you have to try and try to fit these networks with a lot of data. So notice here the process how is different. If a child looks at a bottle, he will immediately realize that this is a bottle. In a system, you have to provide many different pictures of the bottles. Also in all the possible ways, all the possible perspectives, because every time you see from a different viewpoint, this is a different image. So think how many images you need in order that on the next image, in the real life, it will be able to understand that you already have seen this image and that there was an algorithm that have already set the parameters. So when people talk about neural networks that do prediction, I think that this is wrong, it's misleading at least. So neural networks just view at the past history and try to understand what the novel object they are seeing is is closely related to which other road sign they've seen in the past. So this is the point. These are just ways to look at the past in a very smart way. But they look at the past. They don't invent the future. They look at the past. So when your car sees a stop, it will check against all the stop you have already seen in the learning phase. If it finds something similar, then it's a stop. Otherwise, with probability 1.5, it will make a wrong decision. Right? So this is the point. So why I made this? And then another element. So this is a neural network in action, just because I want to provide you with a very simple example. This is a neural network that recognizes handwritten digits. And why I put it there? Just because I want to show you that there is an input, so these are the handwritten digits. Then the output is just this, the fact that one of the digits is selected. And I'm just interested in this picture now. So I think that you can see that the neurons, these points, are organized in layers, right? Can you see that there are basically 3 layers? So there is an input, the handwritten digit on one end, then there are the 3 layers, and finally the result. So these are standard neural network. When the 3 layers becomes 100 of layers, we typically talk about deep learning. So deep means that the network is deep. So it's nothing different from what I've just told you. Just it means that we have 100 of layers. Well, we start talking about deep after 10 layers. Okay. And now, how this is related with large language model. So this is the main point I would like to take you on. So again, the architecture is more or less similar. I know that maybe you have heard or you have read papers about encoders, autoencoders, so on. But I want to focus on the conceptual part. On the conceptual part, the conceptual side, we still have a neural network. The neural network still processes numbers and still do addition and multiplication of the numbers, nothing different. But now, rather than having an image on as input, we have text. Okay, we have the words. So a word replaces a pixel. That's it. Every pixel now is a word. Then everything is processed. But now, what is the output? In the case of the recognition of a road sign, I have just to say yes or no. Is this a stop or not? In this case, I will not ask anything strange, but I will just ask what is the next word. So again, the number I receive as output is interpreted as the next word. So think about that. So you can see that in Google everywhere, this system were there since a lot of years, right? So you start typing something and then it produces the next word. So essentially, the very basic idea of a large language model is a neural network, and now the architecture should more or less at least clear to you. But with the difference that in input I have numbers corresponding to the document, to the words in a document, and to the output I would like to have the next word. That's it. That's it. So there is nothing more inside this. So what is the point? The point is, if I have to recognize some objects, some bottle, some road sign, I need millions of images. So could you imagine how many documents I need in order to train this system? Really a lot. And indeed, for a long time, we believe that this approach wouldn't work. The real key point is that people did it with all the sentences in the world that are accessible through the web. So this is the impressive point of all this stuff related to large language models. So the model itself is conceptually simple. Of course, there are a lot of technical details, whatever. But the really impressive stuff is that these models are trained with all the sentences you get in the world. For instance, you can have a sentence and you say, shaping the future of education in the age of AI. So one input will be shaping the future. And then you say, okay, tell me the output. Well, at the beginning, the output will be a word that's random. And then you say, okay, I will correct this, and it should predict off. And then you adjust the weights. Then you start again, shaping the future off. and then maybe start predicting something which is completely wrong. And then you say, okay, I will adjust the weights and so that you have to predict education. And you start doing it with all the possible sub-sentences of all the possible sentences in the web. So, this is the interesting part of the large language model. Is this training part. After this training part, precisely in the way the system recognizes a button or recognizes some images in whatever way, the system is able to recognize the next word in the proper way, looking at the history. And so this is the important point you have to take in mind. The next word will be the most probable one. So this is the tricky point. It's clearly the most probable one according to all the sentences you have seen. And this clearly have a number of impacts. So we must clearly recognize that there is no semantics, there is nothing there, except the fact that it's able to predict the next word. For instance, if you start interacting with ChatGPT and say, hello ChatGPT, how are you? This is not a question, this is just a sentence, and you will complete the sentence with the next word. And maybe if you start a sentence with hello, the answer, and the next word will be hello. Then it takes your sentence plus is hello, and then start adding another sentence, another word, and so on. So you have seen that the text really flows. It's just appending one word to another word. So of course you do in a bunch set of words, but these are technical details. Okay, that's it. So we have built a world in which we have this particular AI based on large language models in which everything is based on producing the most probable word based on whatever is on the web. That's it. These are the large language models, in my view. Okay, at this point, I want just to take you some very small detail. I hope that you enjoy it. So why these large language models do not come earlier? So I told you that the breakthrough in the images are of 2012. And why they come 10 years later? ChatGPT comes in 2022. So there is a small issue there. I really went very fast when I told you that the word is represented by it's the same thing as a pixel. And yes, it is, but how to assign to every word a number? So this is really tricky. So you cannot start from the vocabulary saying, okay, I start with the first word, it's one, the second is two, and so on. Why you cannot start with this? Because if you really think about the images, if I take two colors, 20 and 21, do you think that these colors are different from each other? No, they are very close, right? So the closeness in terms of the matrix, in terms of the numbers, correspond to the semantic closeness. So how these are close in terms of how we view this pixel. And we should be able to do the same things over words. So I think that this is a very interesting achievement. So we have to explore a way to map every word into a number. And a lot of researchers did this. This was an interesting breakthrough. This is the algorithm proposed by Joshua Page, who won the Turing Award, which is essentially the Nobel Prize for computer science. And the trick is that I should assign similar numbers to words that occurs in similar context. So even though I do not know the meaning of this word in red, I notice that it happens to occur in the web in words like a bottle of blah blah is on the table. So maybe I also found other sentences in the web where there is written a bottle of beer is on the table. And so if I'm able to see that there are different contexts in which these words can be equivalent replaced, then we should be very close to each other. So it provides a kind of semantic definition without talking at semantic at all, of semantics at all. So this was the technical trick. After this trick, everything smoothly applies. Okay. So I tried to provide you this behind the scene because now I want to focus on some other skills. So first of all, there is an important question. So all these systems are built by engineers, and are we really able to use this system? So this is an important point. So these systems are on the web, these systems are everywhere, you can download, you can pay some switch or whatever. So are we really able to use them by taking the most of this system? So overall the answer is no. And I want to provide you some interesting story. So maybe you know this AlphaGo system. 8 years ago, AlphaGo won against the world champion of this game of Go, which was Lee Sedol. And so this is nothing special. So we know that in all these chessboard games, soon after the computers will win against humans. The interesting thing is that after 7 years, a human again overcome the capabilities of AlphaGo, and the human is Galen Perry. How this was possible? Well, this guy worked in an interdisciplinary team with some engineers, with some computer scientists that analyzed the strategies of AlphaGo. They understood how AlphaGo played, and then he developed a strategy to win against AlphaGo. So that's very interesting. So notice, I will really take seriously this story, because the story of AI has been somehow directed by some interesting anecdotes related to chessboard games. So think about the famous Blue versus Kasparov story. And I think that this story tells us a lot. So, do we really have the competencies to exploit the real power of this system? So, can we use this system to do some creative stuff? Second point, I told you that on this kind of application, humans are outperformed. But, and I present here Daniel Kahneman, because if you really think about what is this kind of competition, so recognizing my phone, requires certainly some kind of thinking. But according to Daniel Kahneman, this is a kind of very fast thinking. So how much time is required to me in order to understand that this is a phone? Nothing, right? It's immediate. And so what happens when we consider other kinds of benchmarks? This is a very interesting benchmark. It's of a different kind. Again, we have images. But now, we are trying to challenge ourselves as a computer science community in order to understand not what is in the image, but what the people in the image are doing. Notice that everything changes now. So I'm not interested in understanding that this is a restaurant, that there are 3 people and so on. I'm just interested in understanding what they are doing. And this is a completely different thing. I'm pretty sure that all of you, as at least once, went to a restaurant, have a dinner with your friends, and after days you try to reason again on what they really want to convey to you in that occasion. Right? So these are kind of thinking that are much more slow, really slow. And they need abstraction, they need common sense reasoning. The task is called the visual common sense reasoning. And notice that there is no benchmark for common sense, right? So it is really hard to build a data set with all the possible situations in everyday world, asking people to repeat it millions of times forever, right? So it's a bit difficult. And so this kind of slow thinking, it's really a kind of competence that will be much more critical in the future. So I think that if I have to focus on something in education, I will certainly give for granted that fast thinking is already a machine. So there is really no story about that. No one will compete on something on which machine already won. So we have to compete on the kind of abilities that really distinguish ourselves as a human, and that will more and more distinguish ourselves in the future. And I think that slow thinking is one of them. Well, there are other skills very important, and I clearly see that you understand this picture. So, all this world that we are building by using generative AI is creating a number of distortions like fake discrimination, but I want to focus also on errors, right? Because one thing that I typically see is that people think that AI only do discrimination, bias. People do not think that the system can do errors. Indeed, they can be wrong. So this is a clear point. So these are artifacts. And this is something for which we need the critical abilities. This is an interesting example. This is precisely a network to realize, to understand objects. For instance, this is a guitar with 98%, and this is a famous paper in which pixels have been rearranged with a very tricky way, and now this is a guitar better than the original guitar, 99%. So these are not biased, these are just errors. So there are a lot of papers, even a Nature paper this year, which just say pay attention because these networks can be easily fooled. Okay, so I think that these are other important skills to have in the future. Now, not going to ask questions. I think that this is the typical kind of question everyone would consider. So, why should be difficult answering question? Well, recall that the question, according to what I told you, is just the starting point of some sentence that will be completed according to the most probable and frequent distribution of the web. So if I write something, draw a room but no elephants, absolutely important that there are no elephants, of course I will get this. So in a sentence with 10 words, if I say 2 times elephants, maybe you think that some elephants should be there, right? So this is the most probable scenarios. Then notice that all these systems use some kind of post-processing approaches. If you want, then we will discuss about post-processing and guardrailing. These are technical stuff. But the large language model will provide this kind of answer. There is another type of skill that I really consider very important. So I asked ChatGPT, this is very recent, so it should work again. Write a verse with the words cheek, night, air, jewel, Ethiopian. And he wrote something like night on her cheek, a jewel by her hair, dark as Ethiopian whisper I heard. Okay. So nothing very special. Okay. But the interesting point is that these words are actually taken from William Shakespeare. This is Romeo and Juliet. And this is the time where Romeo have a look for the first time at Juliet. It was night, and he was so impressed by Juliet, and he says to his friends why he was so fell immediately in love, because it seems she hangs upon the cheek of night like a red jewel in an Ethiop's hair. So what's the message here? Recall that these systems are capable of providing to you the most probable distribution. So you will certainly do not get the most rare distribution. So the kind of language provided by this system is stereotyped. That's it. Because it's the most probable answer, the most probable next word. And so if we really need a competence, well, at a certain point we can decide as a humankind to lose our ability, our language ability, right? But if we really care in our language abilities, then we really need also as a skills the culture which comes from the classrooms. Because this kind of expression can be only known after you read Shakespeare. They cannot be provided to you by chance by ChatGPT. They are too rare, so it's impossible. And finally, the last kind of skill that I really think you have to reason about is the following. In recent years, Google, I think last year Google made a paper, an interesting paper, in which he applied the Turing test in the medical domain. So he did the following. He asked to some patients to evaluate the kind of interaction with their physicians. Okay? But in order to do that, they did a very interesting tweak. So the interaction was just via a tablet, by using a tablet. So why they did this? Because of course they do not want that the interaction is, that their results are affected by the fact that you see that it is not a person, but it is a machine. And have a look at the result. So this blue area is the result related to the humans, and this other area is the result related to artificial intelligence. And what is very impressive is that the empathy of artificial intelligence is much more appreciated than the empathy of the physicians. So I always in the last month, I always provide these slides to my colleague, to my physicians, say, okay, I know that you are saying, okay, ChatGPT can substitute my language abilities, but it will not substitute my empathy. And so I always provide them with this picture. So what I think that we cannot take empathy as granted. This is an important point for educators. We know that empathy cannot be taken for granted. It can be simulated too. This is an important point. Also empathy can be simulated. And so we really need to stimulate the next generation, not only to all the kind of skill I provided you. So critical reasoning, slow thinking, capability of understanding, of trusting, but up to a certain point, machines, language skills, but also empathy. Also the ability to be in a relationship with other people is a very important skill. It cannot be taken for granted. I will conclude by just by just showing you a very small video. So in the process, in Italy, at a certain point, there was a huge discussion, especially in the scenario section of the video makers, of actors, right? Because there was a complaint that this system will have taken the scene, and so a number of jobs would have been replaced. So at a certain point, it happened that a group of young researchers and also young artists contacted me as the Italian Association for Artificial Intelligence, but also Rai Cinema, trying to have produce a small short. So this short had a great success. It was it won the best AI film award in New York. It has been now all over the world, and you can download by RaiPlay. And the title of this short is the prompt. I cannot provide to you the whole short, the whole film. It's 10 minutes, but 30 seconds are really interesting because they really convey to you an important message. That is the final message I want to provide to you. So I hope the audio will be in the room. So this video, this project tells me two things. First of all, by using AI we can create jobs. So this is now a company that is doing the job. It's defining its own way to be artists. Second point, you see that the images are not stereotyped. So you can see there that there is some message. So the world and everything is written by humans. And also they did a number of small retouch to the images and so on. So you can really distinguish between something which is completely artificial and something generated by humans. And third, the next thing is that this is a metaphor. And I really think that the most critical ability we have to define for ourselves in the future is the ability really to understand that the future is written by us. So we really need to take care of it. Thank you.